Welcome to this note-taking listening practice. Today, we will examine the hidden costs of electric vehicles, looking beyond the exhaust pipe to understand the full environmental picture of this growing industry. Before the lecture begins, please take a look at the 5 subheadings on your screen to help structure your notes. You can also download the complete note-taking outline as a free PDF from the description below. Get your pen and paper ready, and let's begin.
Good morning, everyone. Over the past decade, electric vehicles have gone from a rare sight on the road to a major part of global climate policy. Governments around the world are setting big targets. The European Union, for example, plans to ban the sale of new petrol and diesel cars by 2035. And the numbers back this up. Global electric vehicle sales passed 10 million units in 2022, and experts predict that figure could reach 45 million by 2030. The main argument for electric vehicles is simple. They produce zero exhaust emissions, which means cleaner air in cities and less damage to the climate. That is true. But today, we are going to look at the bigger picture, not just what comes out of the exhaust pipe, but what goes into making the car, what powers it on the road, and what happens when the battery reaches the end of its life.
So you're saying electric vehicles aren't actually as green as people think?
I'm saying the story is more complicated than the headline. Let's start with the raw materials. Electric vehicle batteries need several key minerals to work: lithium, cobalt, nickel, and manganese. Each of these comes with its own set of problems. Lithium is mainly mined in a region called the Lithium Triangle, which covers parts of Argentina, Bolivia, and Chile. It is extracted from salt flats by pumping large amounts of salty water to the surface and letting it dry out in open pools. The problem is that this process uses enormous amounts of fresh water in some of the driest places on Earth. In Chile's Atacama Desert, for instance, lithium mining has been connected to falling water levels in communities that local farmers and indigenous people depend on. Cobalt is a different story. Around 60% of the world's cobalt comes from the Democratic Republic of Congo. Human rights organizations have reported serious problems in informal mining operations there, including dangerous working conditions and the use of child labor. It is worth noting that large, established mining companies in the region follow international standards and have been working to improve transparency. But cobalt sourcing remains one of the more difficult ethical questions in electric vehicle production.
Can manufacturers use something other than cobalt? Is there a way around this?
Yes, and this is an area where things are changing fast. Tesla, for example, has switched to lithium iron phosphate batteries for some of its models. These contain no cobalt at all. Other companies are developing battery types that use much less cobalt than before. The trend is clearly moving toward reducing or removing cobalt from batteries altogether, though this is still a work in progress. Now let's talk about manufacturing. Building an electric vehicle, and especially its battery pack, requires significantly more energy than building a conventional petrol car. Research suggests that producing a medium-sized electric vehicle creates around 60 to 70% more carbon emissions during manufacturing than a similar petrol vehicle. This means that an electric car actually starts its life with a larger carbon footprint than a petrol car. The important question is, how long does it take for the electric vehicle to make up for that difference through cleaner driving? The answer depends a lot on where you live, specifically on how the electricity in your country is generated. An electric vehicle is only as clean as the electricity that charges it. In Norway, for example, more than 90% of electricity comes from hydropower. An electric car charged there produces far fewer emissions over its lifetime than any petrol car. But in countries where electricity still comes mostly from coal, parts of Eastern Europe, China, or India, the environmental advantage of driving electric is much smaller. In some cases, A very fuel-efficient petrol car might actually produce fewer total emissions than an electric vehicle charged on a coal-heavy grid.
So how green your electric car is really depends on your country's energy mix.
Exactly. But here's something important. As more countries switch to renewable energy, the electricity grid gets cleaner, and that means electric vehicles automatically become better for the environment too, without any changes to the car itself. A petrol car's emissions are fixed from the moment it leaves the factory. An electric car's emissions can improve year after year as the grid gets greener. That is a real long-term advantage. The last thing we need to look at is what happens to electric vehicle batteries at the end of their life. A typical battery pack holds around 70 to 80% of its original charge after 8 to 10 years of use. At that point, it is no longer good enough for a car. Recycling these batteries is technically difficult and currently quite expensive. The process involves breaking the battery apart, separating the different materials, and recovering metals like lithium and cobalt for reuse. Right now, only a small percentage of electric vehicle batteries are properly recycled, and the facilities needed to handle the large numbers expected in the coming years do not yet exist. However, there is a promising solution called second life battery use. When a battery is no longer powerful enough for a car, it can still be used to store energy at home or in a business. For example, storing electricity produced by solar panels. This gives the battery several more years of useful life before it finally needs to be recycled. Companies like Renault and Nissan already have programs for this, and it is becoming an increasingly popular option. So, to sum up, electric vehicles are a real step forward in reducing transport emissions. The evidence shows that, across most countries and over the full life of the vehicle, electric cars produce fewer greenhouse gas emissions than petrol ones. At the same time, there are real challenges in how raw materials are mined, in the carbon cost of manufacturing, in how clean the local electricity grid is, and in managing battery waste at the end of the vehicle's life. Understanding these challenges does not mean electric vehicles are a bad idea. It means we need to work harder to solve these problems so that the shift to electric transport is as clean and fair as we want it to be. That brings us to the end of today's lecture. Thank you all for your time and great questions.
All right, it is time to test your notes. Answer the following questions and check your score. Good luck! That concludes today's listening session. To stay updated with our next videos, make sure to subscribe. Thank you for watching and see you next time. Bye for now.